Can you use a 24 amp connector on a 32 amp ring final circuit? We already know that a 16 amp junction box is not acceptable on a ring final circuit. So why would 24 amps be any different? To answer that properly, we need to look at how a ring final circuit behaves under load. So in this video, we're not only going to find out if this 24 amp connector from QuickWire is okay, but also dive into how a ring final works when we put load on it. Joe Robinson built a test rig and demonstrated exactly how current splits around a ring circuit. So let's dive in and find out.
Ring final circuits. Whether you love them as an example of post-war ingenuity, you hate them for their extra testing and seeming double standards in the regs, they are very much a part of the landscape. I've constructed a ring circuit here. Now you'll notice that between each socket there's a couple of power resistors, one connected to the line conductor and one connected to the neutral. These are just here to mimic the resistance in the cable. Each one of these is the same value of 0.22 ohms. This would represent a ring final circuit where each piece of cable would be exactly the same length between sockets. The legs of the ring are wired back to this BG consumer unit and connected into this RCBO. Now I'm going to plug in a 2 kilowatt load in different positions in the circuit and look at how the current splits. So we'll expect the current drawn to be 2 kilowatts, so 2000 watts divided by 230 volts, which is about 8.7 amp. This socket is the midpoint of the circuit, so that means that the resistance of the conductors here in this path is the same as the resistance of the conductors in the other path. We are measuring, let's have a look at that, somewhere in the region of 4.3 amperes. And then if we go up here, somewhere in that region, we've got 4.2 amperes there. So we've got just about the same amount of current in both of those legs, and add them together and we've got about the current that we were expecting.
Nice even split, half the load each way. But this is a perfect midpoint. Equal resistance, equal path length. BS7671 does not assume that every socket sits at the exact midpoint. Appendix 15 sets out the design principles for ring final circuits. The circuit is only permitted where sockets are reasonably distributed and the floor area does not exceed 100 square meters. The design relies on diversity and reasonable load sharing. It does not rely on a guaranteed 50-50 split. And that matters when we start talking about 24 amps.
Watch what happens when we plug this load into a different socket. Current has increased here. We're now in the region of 5.4, 5.5 amps. And if we go and measure the current in the top leg of the ring, you can see now that we've got 2.8 amperes. So that's quite interesting. We can see that the current is not splitting evenly between the two legs of the ring. Why is that happening? From here to the consumer unit, there's only 0.44 ohms of resistance in the cables, whereas if they go this way, they've got 0.88 ohms. Most of the current will flow this way, where there's less resistance, and less will flow in that direction. Let's do it again. This time we're going to put it in the socket that's right next to the consumer unit. You can see now we've got about 7 amps there, and if we look at the top, once again you can see we've got about 1.4, 1.5 amps flowing through that one there. The vast majority of the current is running through this leg of the ring back to the consumer unit. Now at this point we can look at this and think, well, that amount of current is not such a big deal, but let's load it up a bit more and see what happens. So now we've got about 5 kilowatts connected to the circuit, and let's measure the current flow. And you can see there we've got over 16 amps is running through this leg. Not a crazy amount of load, but clearly more than 16 amps flowing. And that's the reason we can't use a 16 amp junction box to extend a ring final circuit. Can't assume the current will split evenly between the two legs of the ring.
Joe has just demonstrated more than 16 amps flowing in one leg of that ring final, and that was not an unrealistic load. But it does demonstrate why 16 amp junction boxes are not suitable for ring final circuits. Regulation 433.1.1 requires conductors and accessories to be protected from overload in accordance with their current carrying capacity. A 16 amp device could be reasonably overloaded, but 24 amps is not 16 amps. And here is something that often gets missed. 2.5 millimeter squared 70-degree thermoplastic insulated cable installed in thermal insulation can have a current carrying capacity of around 21 amps once correction factors are applied. So under that insulation method, the cable can effectively carry 21 amps. The basis of a ring final circuit is it's not expected to sustain a high current in one conductor for a long period of time. If one leg was expected to carry 32 amps continuously, the 21 amp cable would be overloaded well before the protective device operated. Therefore, the design assumption behind regulation 433.1.204 is that high current will be shared and that sustained overload in a single leg is not normal operation. So the real question becomes this. In a compliant ring final circuit designed in accordance with Appendix 15, is it reasonably foreseeable that more than 24 amps will pass continuously through a single joint? If the answer were yes, then the entire regulatory basis for protecting 2.5 millimeter squared cable with a 32 amp device would fall apart. So when a 24 amp QuickWire connector is used as a maintenance-free joint or a spurred connection point, it's suitably judged against the realistic conditions of a ring final circuit, not the theoretical maximum rating of a protective device used in isolation. The 32 amp device protects the ring as a system. The 24 amp connector sits within that system based on the diversity assumptions set out in BS 7671. So, can you use a 24 amp QuickWire connector on a 32 amp ring final circuit? Well, yes you can. If you want to get more detail on these connectors from QuickWire, then check out the links in the description. And if you want to find out more about ring final circuits, then check out the video on screen now.